No, interesting question. I mean, the ethics is a complicated area because, we're used to doing science, and one feature of science is we imagine that we can kind of separate off the thing we're looking at from everything else in the world. Ethics probably doesn't work that way. People try and pretend that ethics works that way by inventing, trolley problems and things like that, where it's just, you kill the herd of llamas or the three giraffes or something. But ethics, strangely, unlike most of science, sort of everything gets connected to everything. So it really isn't, it's something that doesn't have the same kind of modularity, the same kind of sort of, we can think about this without thinking about that character that we're used to in science. So I think this question of to what extent, how do we think about ethics in when we can't predict what will happen in all cases? It's a very interesting question. We don't know the answer. I think that the thing to realize is that it is more similar to what we had in the past. Okay, so maybe an interesting thing to say. One of the features of current times is people believe very heavily in quote science and what they imagine science to be. What they imagine science to be is often what science was in the sort of pre-computational time, when science was about, we can write down a formula for what's going to happen in this case. And so people imagine that there's a degree of predictability to the world, and therefore they build their ethics on this notion of predictability. That notion of predictability wasn't there before these formula type science came into existence, and it isn't there now because we now understand that there's computational irreducibility, and from within science we're being shown there isn't that kind of predictability. So what happens, the kind of ethics that you set up when you believe you can predict the world is a kind of ethics that has actually become somewhat common in modern times, and it's really wrong because, in fact, the world is not as predictable as you thought it was going to be. I mean, we saw this big time with the pandemic and many aspects of the pandemic, that there were some things that were predictable, but there was an awful lot that was actually a more complicated story where kind of the glib version of science saying, oh, we can just put it in our formula machine and predict the answer. That wasn't reality. So I think the rethinking ethics in a sort of time of computational irreducibility is in part going back to some of the ethics that we had thought about before we had this notion that science lets us predict everything about what's going to happen. These are not easy questions. So I think the first thing to realize is that, okay, so, in human society, there's a question of whether certain things that we view as ethical are inevitable features of having a cohesive society. That is, if it wasn't for those things, then everybody would have killed everybody and there wouldn't be anything there. So in a sense, there may be some aspects of what we see as being ethical behavior, which is sort of a inevitable emergent feature of a society that can persist. So that's one sort of thing to think about in terms of, what should the AIs do? Well, it's partly a question of, the AIs left to their own devices will just do computations, and there's not really an ethics story to that. Ethics is something that relates to us humans and whether the things that are happening are things that we humans feel should be happening. And so there's necessarily sort of a human in the loop story to this question about ethics for AIs. And now then the question is, one question is, how do you capture the ethics of the humans, even if you had a way to impose those ethics on the AIs, how do you capture the ethics from the humans? And so, one thing people say when they first start thinking about this, they say, let's just have the AIs behave the way humans behave. And then people say, wait a minute, that's not a good idea. Humans do all kinds of crazy stuff. We don't want the AIs to just do what we actually do. We want the AIs to do what we aspire to do. Okay, well, what do we aspire to do? Well, that's a much more complicated question. You can go back and read, religious texts or self-help books or, various kinds of things about, what do we aspire to do? it's not a thing for which we can just say there's ground truth because that's what we actually did. And so it becomes it's a complicated question. How to even capture what we might aspire to do. So there are very practical cases of this, like, you're ranking results in social media platforms and things, and you're saying, how should I rank these results? Well, you could say, well, there are different kinds of aspirations I might have, and if you can capture, if there's some entity, organization, belief system, whatever, that has, if we can capture its sort of ideology, its ideals, its values, and sort of and kind of communicate those to an AI, then you can say, well, I want my social media feed ranked according to these kind of aspirational ideas of, cultural system X. And I think that's a thing we don't really know how to do it yet. It's within reach, I think, to be able to do those kinds of things. I mean, people are doing experiments with, given these terms of service, for example, have the LLM read the terms of service and then tell you whether the prompt you're giving for the image generation system satisfies the terms of service or doesn't. That's a sort of beginning version of this kind of thing, where the description language in that case for the kind of ethical system is legal terms of service. I happen to think there's an interesting opportunity with computational language to have a more precise way to state kind of legal types of things than we have with natural language and legalese, so to speak. And that's another kind of frontier, a sort of question of what does it look like in a world where we can specify contracts in computational language. I mean, one thing that people might say, oh, the lawyers are going to be out of work. Quite the contrary. It'll be like the paperless office from desktop publishing and so on. Actually, what will happen is there'll be many, many more contracts, because contracts, their creation and execution will be much cheaper. And so there'll be many more things where you can kind of say, well, why did that happen in the world? Oh, well, we can see there's this chain of 20 contracts that got used to determine that this happened and that happened and the other thing happened. So I think and then, the whole question of computational irreducibility in a world where the rules now, the natural laws are not natural laws, they're laws imposed by human contracts. So it's actually, the word natural law originally arose from this idea that, God was making laws just like we humans make laws about things we do in the world. And that's kind of the notion of natural law. And now we're in a sense, we can make a scientific question of what happens when we make these computational laws that, what does the big, what do all these entities that are operating according to computational laws, what emerges from that? What kind of sort of societal structure emerges from that? And I think it's also very much related to economics, where there's sort of questions about economics is in a sense in some ways a more measurable version of a lot of these societal questions. And there's sort of a question that I've certainly been interested in about what is the foundational, how do we think about economics foundational? I mean, economics has a very strange status in the world because it's kind of it's something which is partly a descriptive science that just says, here's what happens. We can do statistics about what happens. And it's partly a sort of axiomatic science where we say, we assume people work this way, so these are the consequences of that for what happens in economic systems. But I think there's kind of I sort of suspect that there's a way of thinking about kind of economic systems in bulk that perhaps is even related to our physics project. I mean, kind of the way to think about that is in our physics project, we're thinking about these events that are the updatings of this giant network that represents the structure of space and the universe and so on. The little events that happen, the little microscopic updatings of that. In economics, the analogous events are transactions. And so, if you're saying somebody's got an apple, somebody wants to get an orange, in principle, there's a chain of, 50 transactions or something in which somebody barters the apple for something else and barters it for this and barters it for that, and eventually gets to the orange. And that's sort of the thing that makes up the economic system, is this set of microscopic transactions. And one question is, does there emerge kind of a thing that is human understandable from that giant network of microscopic transactions? So one guess that we have right now is that the notion of price, which is to say, well, whether this barter is going to work or not depends on whether an apple and an orange are worth the same amount to have the same price. That notion of sort of simplification is similar to the way that we sort of simplify this giant network of structure into kind of space as we experience it. That the notion of price is a simplification of what is underneath that is similar to the simplification that is what corresponds to space as we experience it, emerging from this underneath complicated network of events. Well, I mean, the world will change as it has done in the past. And the things, if we look from today and we say, what does it mean for, how will the world be N years from now? And we say, oh, they're these humans and they've got these neural implants and they're using AIs and the humans are kind of just doing what the AIs suggest. And, this is, from our point of view today, it may look like terrible. This is not what we want to have happen. Similarly, from 1,000 years ago, if you look at the world today, there are many aspects of the world today that many people from 1,000 years ago would say, that's totally shocking, that's terrible, that's existential, that's whatever. That's, this type of idea, for example, has gone extinct in the world today. And, I think in terms of, so it's a slightly complicated question. It's a more nuanced question. I mean, is it like, the AIs are going to wipe out the humans? It's kind of like, an asteroid wouldn't wipe out humans, but some other, a black hole that comes through the solar system, that would wipe us out. Is that what's going to happen with AIs? I don't think so. Is it going to be the case that the way we live in the future will be different from the way we lived in the past, and maybe a way that some people would say, this is fantastic, and some people will say, this is terrible? No doubt. But I think it's a bit of a nuanced answer. And I think this question of, will we humans just sort of say, yeah, there's nothing for us to do here? No, that's not going to happen, because there are always, the lesson of history is that there are always these new things. When we automate some things, that opens new opportunities, and then there are still more things for the humans to choose or not choose to do. When it comes to, will some terrible mistake happen and, we'll build autonomous weapons and the autonomous weapons will exterminate everybody? I think there are scenarios where I can imagine things like that happening. They are scenarios that would be, I think, as soon as it is the case that there's sort of a society of AIs, there's a large number of AIs that are kind of each, if there's one all-powerful AI, the omnipotent AI, then that's a very fragile, unstable situation. It's not what's going to actually happen. What's going to actually happen is kind of a large number of AI-like things all interacting with each other and, all sort of in this dynamic equilibrium, just like, it's like the apex predator of the world, so to speak, didn't wipe out everything else. It's, it's the same type of thing, that there's sort of an ecosystem that develops, and that's my guess as to what will happen. I mean, there certainly, you could imagine, you could go a little bit the other way. You can say, some government, the world government could decide, we're just going to have one AI in the world, okay? If that really worked, which it probably wouldn't, if that really worked, then there's bad things that would result from that. There are things which generally, for most of us, we'd think were bad. This is one of these complicated things, because anything like that, people say the humans are ruining the planet. How do we not ruin the planet? Well, if you don't have any humans, then humans are not going to ruin the planet. So it's kind of like there was a nice the one way that we can do no harm is not to exist. And that's probably not what most people would say was the right answer, but I'm sure you'd find somebody who would say that was the right answer. And so I'm sure that the same thing is true with this kind of question about sort of what direction AI goes in. Well, okay, so research. First point. Across all different fields, sort of the future is going to be computational X for all X. So the thing to really, the thing to think about is, how do you formulate the questions you are thinking about in computational terms? And my own effort to contribute to that has been building our computational language, a Wolfram language, to provide a sort of notation and a medium in which to think about things computationally. So first thing to say is use computational language to formulate the things you're thinking about, whatever field you're in. And if you're in a field which has not seen computation yet, then you have even more mileage to make progress. So I think that's the biggest practical thing to say. In terms of the kind of studying, there's a huge science of LLMs and AI and so on, of what, it's like we've got neuroscience, we can study a little bit about how brains work. It's much easier to study an AI than it is to study a brain. And there's a lot we just don't know about how those things work. I don't know how far we're going to be able to get in making kind of a human level narrative of what's going on. But that's definitely a direction to push in. I would say that the kind of, what can you do in all fields X? The big story is computational X. The AI X is a subpart of that story. There are things that you can do by saying, oh, we'll get an LLM to do this, and that's a good sub-piece. But sort of the bigger story is how do we formulate what we're thinking about in this kind of in these computational terms, because then we can get our computers to help us. We have a whole sort of a shared formalism between all these different fields, just as we have with mathematics. We got this one kind of idea of mathematics, and we apply it to all the different mathematical sciences. I think that's sort of the big opportunity, is take your field X and make computational X. And some of the questions that have been traditional in fields are different than the questions that are now made accessible by computational X. And that's another challenge, because often fields develop. I mean, the usual pattern of the history of science tends to be, and technology for that matter, is things go for a long time, and then some methodological advance happens. And then there's a rapid opening up of new possibilities. And there's 5, 10, 15, whatever years of kind of low-hanging fruit to be picked. And then things go into this incremental progress, and there are all these, the science becomes highly institutionalized, and there's a, professional society, and there's this and that and the other, and then there's 100 years of slow grinding until some methodological advance happens, and then there's this moment of progress. The thing that we get to do in these times is this idea of computation is a kind of meta methodology that can be applied in all these different areas. As it lands in each area, there will be this period of rapid growth. And that's, I think, for researchers, that's just a tremendous thing. And the sort of the trade-off as a researcher, you can either go into an area where it's well developed, everybody knows what the rules are, you kind of, everybody knows what the questions are, and that's one type of personality researcher. The other one is you go into an area where it's a fresh entrepreneurial area where you can make a lot of progress because even the easy questions haven't been answered. And there's very low-hanging fruit to be picked. That has it requires, like anything entrepreneurial, it requires a bit more sort of personal initiative and a bit more telling other people, why should you care about computation or whatever it is? People haven't known, and why in that field X, people would say, wait a minute, you're answering questions that we never asked. We don't care about those questions. And, well, then you have to explain why those questions are important for making progress in some particular area. But that's, I think computational X is sort of the big story of of where researchers should be going.